Right, here we are at lesson 13, where we will be thinking about this question. Why is creating a common numerator helpful when comparing fractions? So, as usual, make sure you're ready to go. Name on your paper, date, all set up in a place where you can take nice, neat notes. And when that is the case, you may proceed. All right. So, we've learned, you're not supposed to see that yet, we've learned many ways to compare fractions so far, including using benchmark fractions, modeling the fractions using tape diagrams and number lines, and finding a common denominator. Sometimes it makes sense to compare fractions by finding common numerators. Let's compare 2/6 and 4/10. I notice that the numerators are related to 4. 4 is 2 times as much as 2. We can rename one of the fractions to have the same numerator as the other fraction. Let's rename 2/6 using multiplication so that the numerators are the same. 2/6 is equivalent to 4/12. Now it is easier for me to compare 4/12 and 4/10. 4/12 is less than 4/10 because twelfths are smaller fractional units than tenths, and we have the same number of units. 4 of a smaller unit will be a smaller fraction. This is a model to show the comparison of the fractions. It shows the two number lines, one showing 4/12, which is equivalent to 2/6, and the other showing 4/10. We can see that 4/12 is less than 4/10. Let's look at the same fractions, but this time let's rename 4/10 to an equivalent fraction so that both of the numerators are 2. To do this, we can use division. When we divide both the numerator and the denominator by 2, we see that 2/5 is an equivalent fraction to 4/10. Let's compare 2/6 and 2/5. Sixths are smaller units than fifths, so 2/6 is less than 2/5. Let's see what this looks like using tape diagrams. These tape diagrams show 2/6 shaded and 4/10 shaded. However, if we group the tenths together in groups of 2, we can see that the bottom tape diagram shows, we can make the bottom tape diagram show fifths. We see that 4/10 is equivalent to 2/5. Once again, to compare the fractions, 2/6 is less than 4/10 or 2/5. Look at these two fractions, 9/12 and 3/5. To compare these fractions, it makes sense to start off comparing them to 0, 1/2, and 1. Both of these fractions are greater than 1/2 and less than 1. It is difficult to compare with just using benchmark fractions. Next, we could look at the denominators. Unfortunately, 12 and 5 are not related numbers, so that doesn't help either. Looking at the numerators, they are 9 and 3. Those are related numbers, so we may be able to use multiplication or division to make common numerators, then compare the fractions. 3 times 3 equals 9, so if multiplying the numerator and denominator of 3/5 by 3 will give us an equivalent fraction. We can more easily compare 9/12 and 9/15. They are both 9 of a unit, but one is 9/12 and one is 9/15. Twelfths are larger units, so 9/12 is greater than 9/15. Another strategy is to use division to a common numerator. We still know that 9 and 3 are related, but this time let's think about the fact that 9 divided by 3 equals 3. We can take the fraction 9/12 and use division to find an equivalent fraction to help us compare. 9 divided by 3 equals 3, so dividing both the numerator and the denominator of 9/12 by 3 will give us an equivalent fraction. We can more easily compare 3/4 and 3/5 because now they have the same numerator. Fourths are larger units, so 3/4 is greater than 3/5, which means that 9/12 is greater than 3/5. So let's reflect. As you get to work today, how is creating a common numerator helpful when comparing fractions? Also want you to think about, when is this the right strategy to use? So we've learned how to use benchmark fractions, common denominators, and now common numerators. And your job is also going to be matching the strategy to the situation. Enjoy your work.